Hello, welcome to another class with me. Today we talk about logic. This is the part 2 of logic. When we talk about a mathematics, we want to do a proof. That is, a proof is usually when we want to prove a particular statement or particular claim to be true. And usually in mathematics, this claim usually can be rephrased as an implication. That is, if a particular condition is true, then you have a particular result. So this is usually what we call an implication. That in English, if-then statement, right? If-then sentence, for example. This sentence can be true or false again. So implication is a type of proposition, all right? So usually we have P with an arrow like this to Q. So this is read as P implies Q. So P is the condition. If you have P condition, then Q is the result, right? Another way that we can look at it, P is the sufficient condition for Q, right? And Q is the necessary condition for P. So P is the sufficient condition for Q. It's easier to remember this if you use an example. For example, right? If Sonam is in Karizawa, then Sonam is in Japan. So here I have an example, right? P is Sonam is in Karizawa. So this is my condition. And then Q, Sonam is in Japan. Right? So, and you know this to be true. If you know that Karizawa is actually in Japan. So if you happen to be in Karizawa, then you must be in Japan. So that P here, if you have satisfied condition P, then that alone is sufficient to tell me that Sonam is actually in Japan. Now, however, if you reverse this, if you know that Sonam is in Japan, does that mean Sonam is in Karizawa? Well, not necessary, because Sonam could be in Tokyo, or could be in Kyoto, or could be in Hokkaido. Being in Japan itself doesn't mean that you have to be in Karizawa. But being in Japan is a necessary condition for somebody to be in Karizawa, because first you have to be in Japan to be in Karizawa. So Q is the necessary condition for P to happen. And P is the sufficient condition for Q. So if you are actually in Karizawa, then you must be in Japan. So that is sufficient to establish that you are actually in Japan. So P implies Q. It's read as P is the sufficient condition for Q, whereas Q as a subject is the necessary condition for P. And we can also represent this using a Venn diagram, for example, right? And let this be the universe. And inside I have P, that's Karizawa, that being in Karizawa or anywhere near Karizawa, right? And we have another thing out here, Q, that represent Japan. Oh, remember, this is capital P, this is capital Q. So capital P could be Sonam is actually in, for example, in Naka Karizawa or Q Karizawa, or it could be in Isaac that is in Karizawa. Q is in Japan, anywhere in Japan. So when you have this P, right? P inside of Q, capital P is a subset of capital Q, then we say that the P implies Q is true, right? Otherwise it's not true, right? So when is it not true? Well, if you have a situation like this, right? So this is my P and here is my Q, for example. In this particular case, P is not a subset of Q because there are regions around here where it is not part of Q, not a subset of Q, then in this case we cannot conclude P implies Q is false in this case. Right. So if capital P is not a subset of Q, then P implies Q is false statement. Right.